All right, here we go. We're talking about isosceles triangles. First of all, how do you know that this is an isosceles triangle? Two sides are the same. That's what these marks mean right here. Okay? Vertex angle, the angle determined by the equal sides in an isosceles triangle. A is your vertex angle. Okay? Where the two sides come together, bam. That is your vertex angle. The base, obviously, is the opposite of the vertex angle. Okay? The base angles, the two angles whose vertices are the endpoints of the base. Sounds really confusing, but it's not. These two right here are your base angles. Okay? The base angles are opposite the equal sides too. Okay? So, isosceles triangles. If I ask most people in this room to draw a triangle right now, this is the triangle you will draw. I've done it before and then we measured the sides, and almost 80% of them are isosceles triangles. It's really cool to do. Okay? So, theorems. There are a bunch of them. No one probably copied them down ahead of time, right? Did anyone read them ahead of time? Mm-hmm. Wow! 4 of you. I'm pretty impressed. I'll give you a moment to write it down.
Is it in Detroit?
Yes, it's right on 7 Mile.
What is it? Like 4 miles? I thought it was.
All right, isosceles triangle symmetry theorem. The line containing the bisector. What's the bisector of the vertex? What does that mean? These two angles are the same, correct? I did not put it on the thing, but I just want to talk about it. Okay? This becomes the line of symmetry. What does that mean? If I fold it over, they perfectly match up. Okay? This is the line of symmetry. The line is M. A, B, C. Remember your base angle, vertex. Opposite side is your base. So M, the line that cuts through A, is also the line of symmetry. Okay? I like this one, the isosceles coincidence theorem. Write that one down for a moment. Okay, here we go, the isosceles triangle coincidence theorem. In an isosceles triangle, the bisector, again, this is your bisector, they're the same, of the vertex angle, the perpendicular bisector of the base, and the median to the base determine the same line. What that means is if you have M coming through here, M creates a bisector of the vertex, perpendicular bisector, which means this is divided into 2 equal halves, so I could do this. Okay? And the median to the base. Okay? Now on the first slide, what was the definition of median? The middle. Divides it into 2 equal parts. Okay? That is the isosceles triangle coincidence theorem. I believe there is one more. And actually, this is the most important one. Okay, here we go. The isosceles triangle base area angle theorem. This will be very helpful for your homework. Yes, you have homework. I'm sorry. Okay, if a triangle has 2 congruent sides, then the angles opposite them are congruent. If these 2 sides are equal, the angle opposite are equal. Okay? Remember, these are called what kind of angles?
Base angles.
The base angles are always congruent in isosceles triangle. So, if the measure of angle A, I don't know how that got there. If angle A was 30 degrees, what's the measure of angle B? Huh? 75. How did you get that?
Gotta add up to 180.
Has to add up to 180. So triangles add up to 180. You minus the 30. You had 150 left. And why did you divide by 2?
There's 2 angles.
Now they're congruent, so you divide it by 2, and you got 75 degrees. Now remember, this is advanced geometry, so you may have the measure of angle B is x plus 17. I'm just making this up. We're not going to solve it. Measure of angle C is 4x minus 12. If I asked you to solve for x, what would you do? Remember, when you have these, either you add them, subtract them, or set them equal to each other. Set them equal, okay. Okay. Oh, you knew the answer? All right. Yes, there's your homework. Go. Write it down.
I was trying to get a straight face. So I can't do that.
There you go.
You go up there and down here.